So last time it was product rule and quotient rule that I posted a video, but I'll do a few more problems on it. Product rule today, quotient rule on Wednesday. That should do. But before we start, I'll get into higher order derivatives. It's nothing complicated. Whatever we have as dy divided by dx is simply the first derivative. So you have y prime. It is the same as f prime of x. For some function y equals f of x. Good. What does a higher order derivative mean? If you have y prime and you took the derivative again, we get the second derivative, which we denote as y double prime. So that is the first derivative. This would be the second. And whatever answer you have, you take the derivative one more time. Any guesses as to what we would get next? Third. And we could repeat the process over and over and over again, all the way up to the nth derivative. We like to put it within parentheses because I don't want a whole bunch of primes, right? That will look ridiculous. So even for the first derivative, I could write it as y raised within parentheses 1. Second derivative, y raised within parentheses 2. Third derivative, y raised parentheses 3, and so forth. Good? So this would be the nth derivative. As far as this class is concerned, we're not going to go past the third derivative. But in practice, though, we can go all the way up to the nth derivative. Oftentimes, certain algebraic functions, almost all polynomial functions, would eventually become 0 if you keep on taking the derivative. But there are other functions which you would keep on taking the derivative, it will never become 0. Good? So all you have to do is a higher order derivative, or remember, is that a higher order derivative is simply a derivative of a derivative that you keep on taking. Does that make sense? Okay. Going to erase. Even before you start, how would you go about finding the derivative of that? Any thoughts?
Number one, deal what's outside deal what's inside the parentheses first.
Okay, how would you deal with that? Just erase it?
Well, no. Okay, fair enough. But pretty much put it down to its simplest, to its derivative form.
So you'd distribute it, and then you'd have a bunch of terms that are in sum, and we know how to take the derivative. You take the derivative of each term, and that is easy. But I'm going to find the derivative using product rule, because if I look at this, there is one function, f of x, and there is another function, g of x. Yes? And they are multiplied together, so you have f of x multiplied by g of x. We like to write it in shorthand notation. We usually say u and v. Got to be careful with product rule, because it could result in skin cancer. You know why? No? UV. Okay. Standard formula, you don't have to memorize this, but you can put it in the cheat sheet if you want. So, we have identified U, we have identified V, and all we have to do is plug it in this formula. What does the formula state? You keep U as is, find the derivative of V, multiply them. Keep V as is, find the derivative of U, multiply them, and add the result. U in our problem is x squared. V is x squared plus x plus 1. Yes? I am sure that you must have done the homework by now. What is the derivative of x squared?
2x.
2x. What is the derivative of v prime? In other words, the derivative of that entire thing. 2x plus 1
plus nothing, because
plus nothing, right? The derivative of a constant is 0. So that is our answer. What does the rule state? The rule states u, v prime, we multiply those two, v, u prime, we multiply those two, and we get the answer. X squared multiplied by 2x plus 1 plus v is x squared plus x plus 1. Multiply that by 2x. Do we see anything in common between that term and that term?
The x squared and plus 1. And wait, everything but the x, basically.
Everything but the x is in common?
Yeah.
Okay, anyone else? First term, second term, do we see anything in common? Is this term there?
Yes.
Who said yes? I think you need glasses. Is that term over there? Do you see it?
as the derivative.
Yeah.
Right, but I want to know, do you see this entire thing over there? No, so this term is not in common. Do you see 2x plus 1 over there, the entire term? No, that is not in common. Is 2 in both terms?
Yes.
True. I wouldn't disagree. You have x here, and you have x squared. Do we have something in common? What is x squared? It is x times x, correct? So there is an x. So x is in common. So if I pull that out, I like to change them to brackets so that we can understand it better. If x is pulled out of x squared, what do you leave behind? X. And that term remains as is. Agreed? That term will remain as is. We pulled the x out. What are we left with?
2.
Just 2. Always simplify. Distribute the x over there. You have 2x squared plus x. Distribute the 2x squared plus 2x plus 2. What is 2x squared plus 2x squared? X plus 2x. And that 2 remains as is. Earlier when I started, Matthew? No, what's your name?
Me. Bracken.
Bracket. So earlier he mentioned that we can distribute and find the derivative directly. We could have done that. In this problem, which is easier, distributing and finding the derivative, or using the product rule, distributing and finding the derivative. I did this so that I can show how product rule works. But in practice, it is your choice to determine which would be easier, right? What do I mean by that? The original function was y equals x squared multiplied by x squared plus x plus 1. Yes? And if I distribute, what would I get? Go ahead.
X to the 4.
First, you have x raised 4 plus
X to the 3rd.
plus
X squared.
x squared. What is the derivative of x raised 4?
4x the square.
What is the derivative of x cubed?
2x.
3 comes to the front,
Oh,
and what do we do to the power?
minus the side.
1. So 3 minus 1 is 2. What is the derivative of x squared?
2x.
2x. What do we have in common between that term, and that term?
An x.
X. If I pull that x out, I have 4x squared. Pull the x out of 3x squared, you have 3x. X pulled out of 2x will just give you 2. Correct? Now look at that answer. Look at that answer. Are they different? One and the same. So in a problem like this, which one would you pick? Product rule or this? Obviously this, right? Because this is easier. With me? So it is a matter of choice. Do not go for product rule unless it is absolutely necessary. When you do the homework assignment though, it would clearly state, oh, use product rule. There are problems where you will have to use product rule to get the answer. Good. Again, doing this by distribution is the easiest approach, but I want you guys to be familiar with product rule, which is why I'm going to do it using product rule. Which one should be u 3x to the third? Which should be v?
X squared plus 5.
Here is a question. Does that really matter? Does it matter if I call that u and that v? No, because a times b is the same as b times a. So in product rule, you can switch u and v, and the formula will not change. Put a note on the side. With quotient rule though, you cannot switch u and v. Here it's fine. When we do quotient rule, you cannot do that. Then the formula will change. Good? U is 3x cubed. V is x squared plus 3. What is u prime? 9x squared. Very good. What is v prime? So close.
Just 2x?
Just 2x. What is the derivative of a constant? 0. U, v prime, plus v, u prime. What is u? 3x cubed. V prime is 2x. V is x squared plus 3. U prime is 9x squared. I could multiply these two and write it as 6x raised 4, correct? I'll keep that as is. Nine is divisible by 3, correct? You can divide 9 by 3. Can we divide 6 by 3? Yes. Which tells us that 3 is in common between those two terms. Agreed? What else is common? X raised 4, x squared. What do you think is in common? X squared. So if I pull 3x squared out, took a 3 out of 6, we'll leave 2 behind. We took x squared out of x raised 4, we will have x squared. Took a 3 out of 9, we'll have 3. We took that x squared out, so just 3. Good so far? Distribute that. Always try to simplify. It look nice. 3x squared plus 9. And we can add those two because they are like terms. 2x squared plus 3x squared is 5x squared plus 9. Good. Any questions on that? Now, are we done with this problem?
Nope, we gotta do it again.
Why?
Because to find the second prime, you need to take the first prime and distribute it out again. Find the derivative of it.
So, we want to find the second derivative. All we have done thus far is the first derivative. So we have to take the derivative of this derivative to get the second derivative. Good? First, take the derivative. Second, what would happen if I took the derivative of the second derivative? What would I get?
The third derivative.
The third derivative. So I've shown you product rule. I've shown you how to find the first derivative. Use product rule again and find the second derivative for me. I'll give you about a minute or two. And writing it this way helps. Once you practice your law, some of you would be able to do it in their head without writing it out. But try to write it out until you get to that point. So let's find the second derivative. Do we have it? What do we have?
I got 6x times 10x squared plus
6x.
9. 6x on the outside, and then in parentheses 10x squared plus 9.
I see. What would u be in this case?
U would be 3x squared.
3x squared. V,
5x squared.
5x squared plus 9. So the second derivative is u v prime plus v u prime. So we have u, and v prime, oops. What is u prime?
6x.
6x. V is 5x squared plus 9. And what is v prime? 10x. And we take those expressions and simply plug it in the formula. U is 3x squared. V prime is 10x. V is 5x squared plus 9. U prime is 6x. Good. Let's see. 3, 6. We have a 3 in common, correct? X squared, x, we have an x in common, correct? So I don't see anything else being common right now. So we took out 3, we took out x squared, which means we are left with x. That would remain as is, 10x. We took out 3, we took out x, so we are left with 2. X times 10x would be 5x squared times 2 is 10x squared. 9 times 2, 18. Ten x squared plus 10x squared is 20x squared plus 18. Do we have something in common between those two terms? 20x squared and 18? 2. So if we pull out 2 from 20, we have 10x squared. If I pull 2 out of 18, we're left with 9. There is nothing common between those terms, so we would have 6x multiplied by 10x squared plus 9. Good? I'll give you a minute to copy. I'm still writing it down. Yes?
Is there a benefit to like what you're doing simplifying as you go? Because for what I did for that problem is I multiplied all the terms together and simplified at the end.
Mm-hmm.
Is there a difference in between doing?
No, it's a matter of choice. I like to do it this way, but do whatever makes you comfortable.
When we pulled the 3 and the X out for the first time, why can't we touch like that 10X? Like, why is that X untouched?
Hit?
Yeah. Oh, one below it. Like the 3 and the X. So we pulled out the 3 and pulled out the X, but then that 10X stayed the same.
Okay, so I had x squared here, right? X squared has x in it, correct? So you could either pull x from the x squared term, or you can pull the x from the 10.
It just depends on which one.
It's a matter of choice again.
Okay.
As long as you pull the common factor out. Any other questions before we move on? Okay. Now, mind you, this problem is very easy if you did it by distributing, okay? But I want you guys to be very familiar with product rule, which is why I'm going to do it using product rule. So what are we trying to find? We're trying to find the second derivative for a given value of x, and that value is 0. In the last 2 problems, we left x as is. In this problem, we are going to plug in a value for x. Good? The reason being, in one of the previous videos or classes I mentioned, the derivative of any function is a function in and of itself. So, what is the very first step?
Find UV.
Huh?
I was gonna say find UV, but.
We'll find UV, but prior to that, anytime you see a radical, what do? You simplify. How?
Would you square it?
Square? You're getting close, but it's
Cube?
not squaring. It's not cube. What does root x mean? X raised to the power of
X.
x.
No. No.
1/2. So this would be x raised 1/2 multiplied by, okay, let's just extend the same idea, but instead of root x, we have the third root of x. So we have to write it as x raised to the power of 1/3. Yes, u, v. U prime, 1/2 comes to the front. What is 1/2 minus 1? Negative 1/2. One third comes to the front. What is 1/3 minus 1? negative 2/3. U v prime, so x raised 1/2 multiplied by 1/3 x raised negative 2/3 v u prime 1/2 x raised minus 1/2 multiplied by x raised 1/3 plus 1. Damn it. If the bases are identical, what do we do to the powers? Combine. So how would you combine, Liam? Do we add, multiply, divide? You add the powers. If the bases are identical, by base I mean the x. They are the same, so I simply add the powers. Good. Bases are identical, in other words, we have x, x. So we add the powers. Negative 1/2 plus positive 1/3. How do we combine two fractions?
Find the common denominator.
We need to find the common denominator. What is the common denominator of 2 and 3? 6. How do we get that 6? You multiply and divide by 3. So you have 3 over 6 minus. Multiply and divide by 2. You have 4 over 6. Same thing over here. Multiply and divide by 3, you have negative 3 over 6. Multiply and divide by 2, you get 2 over 6. This is just easy. Since we have a common denominator, that common denominator would simply be 6. What is 3 minus 4? Negative 1. Same thing, common denominator is 6. What is 2 minus 3? -1 plus 1/2 x raised -1/2. Takes a lot of patience when you have something with radicals. I'm sure there are a bunch in with the sign. Oh, great. Same term, correct? So let's just call that an apple. You have 1/3 of an apple and you have 1/2 of an apple. When you put together, how many apples do you have? Huh? 2/3? Are you sure? 5/6. Who said 5/6? How did you get that? You did the same thing. We're trying to get to a common denominator. Multiply and divide by 2, you get 2/6. Multiply and divide by 3, you have 3/6. Two-sixths plus 3/6 of the same term would be 5/6 x raised -1/6 plus 1/2 x raised -1/2. Now, if you go back and look at every single problem, we simplified prior to finding the second derivative. I'm not going to do that in this problem. The reason being, at the end of the day, we're trying to find a single value. We're going to plug in a number, get an answer. So all that simplification would be a moot point because you're just plugging numbers and adding, subtracting, or dividing. So I'm not even going to bother simplifying this. Do we need product rule for the second derivative? No, because we don't have two functions in product. All we have is a function here plus a function there. So we can simply take the derivative. Five-sixths. So that -1/6 would come to the front. And -1/6 minus 1, right? We take away 1. Do the same thing with the second term, 1/2. Pull the -1/2 to the front. -1/2 minus 1, you have -3/2. Again, I'm not going to simplify at this step because I just need to plug in the value. What value? 0 to find f double prime of 0. What is f double prime of 0? We simply plug in 0 for x, right? Let's see. Yes? Zero raised any power is 0. 0 raised any power is 0. What is the final answer? 0. So in short, literally, we did all that work for nothing. Does that make sense? So the purpose of, I knew the answer even before we started the problem. So the reason I did this problem is that so you can practice with product rule. And keep in mind, the answer is not always going to be 0. In this problem, it became 0. It could be any number. So, and that is a good place to stop.
What happens if it doesn't become 0?
You'll get a number. Could be 1/2, could be -3/4. You'll have a number as an answer.
Does that mean f of second prime doesn't equal 0 though?
So if you, for instance, if I plug in 1, right, the answer is not going to be 0. It'll be a number. And since you asked, I'll just go ahead. Can I erase this? I'll put it as a remark. I'm going to evaluate the second derivative at x equals 1. So I have 5/6 multiplied by -1/6. 1 raised to the power of any number is 1. I think his breakfast is finally kicking in. 1/2 times 1/2. 1 raised to the power of any number is 1. So we have 5/6 multiplied by -1/6 multiplied by 1. We have -5/36. Yes? 1/2 times 1/2 is 1/4. How do we combine two fractions? Common denominator. The common denominator between 36 and 4 is 36. We've got to multiply and divide by some number so that I get 36 in the denominator. 9. So we have -5/36 plus 9/36. We have a common denominator, so combine the numerators. -5 plus 9/36.
4/36.
4/36.
Which is 1/9?
Which is 1/9. Right?
Oops.
So, if you plug in 1, we get a non-zero number, right? In this problem, plugging in 0 gives us 0. Had it been a different problem, when you plug in 0, you may get a non-zero number like you got it for double prime of 1. Does that make sense?
So if, like an exam question was find f double prime of this function, are we always plugging in 0 at the end? Is that?
No, because the problem would clearly state find f double prime of 0, which tells you plug in 0. If the question says find f double prime of 1, you'd plug in 1. But regardless, in the homework exam, it'll just be one number, either plug in this, plug in that. But it would be specified in the problem itself. Good? That's a good place to stop.